For several years, auto manufacturers and government agencies have sought ways to improve safety on the roadways and effectively manage traffic flow. Wireless communication systems are advancing, and the vision of automobiles talking to each other, known as vehicle-to-vehicle communications or V2V, and vehicles talking to the infrastructure or roadside equipment, known as vehicle-to-infrastructure communications or V2I, is now becoming a reality.
This is a game changer.
Is it possible to achieve no deaths, no crashes, and no congestion on the U.S. roadways?
Everything on a vehicle is software-based or has a substantial software component, and everything is going to be connected to everything else.
What is a connected vehicle, and what does it mean for transportation? Welcome to the Connected Vehicle Professional Certification Microtracks.
My name is Scott McCormick. I'm the president of the Connected Vehicle Trade Association, an organization that was formed in 2004 at the request of the world's 12 largest automakers. This is the Microtracks 1. What is a connected vehicle? A connected vehicle has three primary attributes. It is the convergence of diverse pieces of software and hardware inside the vehicle. It is bidirectional communication to and from the vehicle using any of one of the major protocols, and it is the ability for that communication to connect with other devices inside or outside the car. The purpose of having vehicle connectivity is primarily to reduce collisions, to optimize traffic management, and to provide travel information to the driver. Tomorrow's car is always connected, user-friendly, comfortable, has smart information management, and it is the key to zero emissions and zero collisions. Connected vehicles are wirelessly networked enabled. They communicate with devices inside and outside the vehicle, and they consist of a complex set of electronic components. The vision is collision prevention to enhance safety and mobility and to lower the environmental footprint. The modes of communication are within the vehicle to a personal gadget, the vehicle to other vehicles, and vehicles to the infrastructure, the sidewalk furnishings on the side of the road that the Department of Transportation is used to communicate their information. When we look at where we are in developing the technology readiness to put this equipment and systems onto our roadways and into our cars, we go by what NASA developed. It's called the technology readiness level. And what that is it's a process of looking from the very beginning when the information was originally conceived, going through a level of testing and simulation, creating prototypes, and then putting that into some level of pre-production until finally we can put it into full production on the road. And we are at the top level now. When we look at the technology, there are several different communication protocols that communicate bidirectionally to the car. One is Wi-Fi, one is cellular, one is dedicated short-range communication, which we're going to talk about later. And there are other methods such as Bluetooth and near-field communication and satellite. But those are primarily either expensive, near-field, or extremely long-field. Examples of bidirectional communication, where the communications go to and from the car, include things like cloud services, safety systems that communicate information back to the automaker in terms of the performance of the vehicle, traffic systems that communicate to the car, for example, to say when the light's going to change or whether or not there's a change in the speed ahead, and other vehicles who may have passed along road weather and traffic information coming from the direction you're traveling in. And there's a number of bidirectional use cases. Safety is the primary one. It manages the electronic controls of the vehicle itself. An example of bidirectional communication for mobility would be messages from the infrastructure on road weather and traffic conditions. An example of an infotainment bidirectional use case would be data coming to and from devices in your car from the cloud and for information and entertainment. Each have a different requirement for the speed of the transmission, how it must be secured, the distance that this message can be carried, and the bandwidth that it uses. Some unidirectional examples, in other words, those that can only communicate to the car, or the car can only communicate out from it, are things like satellite radio, high-definition radio, AM/FM radio, and the attachment of what we call nomadic devices, devices that you carry into the car, laptops, phones, tablets, through near-field communication or Bluetooth to an embedded system in the car. Safety is the responsibility of automakers because they hold all the liability. Mobility is the responsibility of transportation agencies. Their job is to manage the macro flow of traffic. And everything else we classify as commercial services for the information and entertainment that it provides. The protocols that we look at are cellular for diagnostics and communications, Wi-Fi for information, dedicated short-range communication for safety functions, near-field communication for authentication, and Bluetooth for entertainment and in many cases for door unlock purposes. And when we look at the devices, they're basically categorized in three groups. If it's built into the car, it's considered embedded. If it's added after the sale of the car, that's an aftermarket device and wired in. Or it can be what we call a pneumatic device, which is carried into the car by the driver or passenger. This could be a cell phone, a tablet, laptop, or some gaming device. The foundation of the connected vehicle technology came about through a collaboration between the 12 largest automakers and three groups under the United States government. One was the Intelligent Transportation Systems Joint Program Office. One was the Research and Innovative Technology Administration. And one was the U.S. Department of Transportation, which sponsors connected vehicle research for the safe, smart, greener surface transportation. The architecture that was developed was categorized and cataloged in a system called the Connected Vehicle Reference Implementation Architecture, CVRIA. And what this did was it established the systems, design, and interface standards for how devices would communicate with each other on the roadside. It was completed in 2014 and has annual updates, and it is available at this link. For the U.S. Department of Transportation, the vehicle-to-infrastructure proof of concept took 5 years. There were 100 different use cases that they were testing. They communicated on dedicated short-range communication at the 5.9 gigahertz bandwidth, and it was a flexible and scalable system. To take a look at the recap of what we're looking at, this chart kind of shows the functions that occur external to the vehicle, in the center column, the functions that occur inside the vehicle, and three of the methods of communicating them from the car to another person to another system.
Gary Strillman, Director of Advanced Engineering and New Concepts at Marelli, gives us some examples of vehicle-to-vehicle communications, or V2V, and vehicle-to-everything communications, or V2X, and how they're used to advance safety.
You're probably aware of the transponder device used in aircraft. It continuously sends out a message saying who they are, and where they're headed. This allows all aircraft to know what the traffic is around them and be able to avoid running into each other. V2X would do the same thing for all vehicles to let other vehicles around them know who is in the area, what they are, and what direction they're moving. V2X would be like putting a transponder into each vehicle that would let the vehicles around it know they are there. There is a message called the Basic Safety Message, or BSM, that's used to broadcast information about the vehicle. Is it a car, truck, bus, emergency vehicle? How fast is it going, and which direction is it going? Then, all the vehicles around it would know if there's any possibility of a problem, like a collision. And if there is a problem, the vehicles can take corrective action to avoid or minimize the collision. A number of use cases have been developed to handle specific situations, like the Emergency Electronic Brake Light, or EEBL. When a vehicle has brakes applied, it will include in the basic safety message the information to let the other vehicles around it know they are starting to brake. So when you are cruising along the road, your vehicle will know within a few milliseconds that a vehicle ahead of you is stopping, giving you the time needed to slow down and avoid a panic stop. In addition to vehicles talking to each other, they could also talk to electronic units installed along the roads at intersections with traffic signals. The traffic signals will send out information about how long the light will stay green or red, allowing the vehicle to know if it will need to stop at the intersection or if it will make it through the green light. If you have several lights ahead of you, the system could suggest a green speed that would allow you to get to the lights when they are green, making your drive less stressful and maybe more fuel efficient. An emergency vehicle has a special code that can alert the intersection that it is approaching and make the intersection safe to proceed through by turning all the lights red. Public transportation buses could also talk to the intersection to optimize getting through by keeping the green light a few seconds longer or turning a red light green a few seconds earlier. This has been tested and proven to help buses stay on schedule with minimal effect on traffic. Michigan has a large base of intersections equipped, and the standard intersection control box defined by the Michigan Department of Transportation is specified to include the capability to broadcast the light timing. Macomb County in Michigan is in the process of equipping all their police and emergency vehicles and 700 intersections with V2X technology to improve safety for emergency vehicles and keep their buses running on schedule. The technology can be extended to pedestrians if we consider sending the same type of signals in a way that could be received by your mobile phone. This would be vehicle to pedestrian, or V2P, and could be extended to bikes and other similar two-wheelers. With most accidents caused by human error, it's easy to understand why the V2X system would be able to mitigate the majority of accidents. It would take 10 years plus to get all the vehicles equipped, but the benefits would be almost hard to imagine.
That's the primer for connected vehicles. Before we move forward, we hear next about autonomy, where we are and where we're going, as the Connected Vehicle Professional continues.